Hello, a warm welcome to youthtutors.com. It's another video, and my name is Ed, and I think you've met me before. And today's topic is indices. Now, these are the beginning of AS, high-end GCSE, and they're going to stretch you a bit, but hopefully you've reached the elastic limit by the end of it, because it won't stretch you anymore. You'll find it a piece of cake. So yeah.
You're not doing physics as well, are you, Edward?
No. Well, I like to diversify it, but
indeed.
Evaluate means solve. It's just a posh word for solve. So
is it really solve? There's no.
Not solve. Sorry.
So
just
simplify.
Work out.
Yeah, work out. I agree.
It's just a.
Okay, so what have we got to do here, Edward?
Okay, so my suggestion is just ignore the minus initially. So just get rid of that minus. We don't like it. So we just cube these numbers. So it's 7 eighths. This is the first step. Times 7 eighths times 7 eighths.
That's clear, yeah.
Now 7 times 7 times 7. You'll need a calculator for this, but it's 343.
Did you need a calculator, Edward?
Well, no, it's just memory, but...
Okay, fair enough. So 7 cubed is 343.
Over 8 times 8 times 8, which is 512. Right, so we've got, this is 7 eighths to the 3. Now, a minus 3, that minus is there just to look horrible. And
what does it do, this minus sign? What's
it just makes it go like that. Whee. So it means it's just flip over the front.
Oh, they flip them over, so it gives you the inverse.
Yeah.
So really, could you jot, just for simplicity, could you write 1 over?
Equals
1 over 343 over 512. Yeah. Okay. And so your final answer becomes, Edward?
Equals 512 over 343. So
that's our final answer.
That's all there is to it.
And that doesn't simplify any further. So that is 7 eighths to the minus 3. Wonderful. Next one, please, Edward. This looks really tricky. You've made up this one, haven't you? Okay.
Yeah. Well, if you spot it, these are actually cube numbers. But they don't have to be cubes. You know, they may be nasty in the exam, but in that
actually, Edward, are they cube numbers?
Yes, they are.
Are they really?
Yes. 27. Sorry, let's do 27 instead of 81. I like that number.
Because 81 would be to the power 3 to the power of 4, wouldn't it?
Yeah.
Could you write that clearly as 27, please, Edward?
Sorry.
That's not.
That was my mistake. 27. Let's do 27.
Okay.
2197. Okay. Right. Well, again, ignore the minus. We don't like it. So it's just to the 2/3. Now, fraction is what freaks people out, and that's maths' purpose, or is it? We like to, but let's just, as with anything, we evaluate it methodically. So it's a.
Do it the way you did before, Edward. Do it the way you did this. The way you did that part there, the 7 8 7.
Yeah.
Can you work it out like that?
There's a rule, which is x to the 1 over n equals n root x. Now
nth root of x, yes.
N is 3, so n equals 3, which means you're finding the cube root of this, and then you square it.
So would you put in x under there? So cube root of
x, and as there's a 2 on the numerator is the power you times it by, so it's this cube root of x squared.
I see.
Right,
okay.
So now let's go ahead and do that. So the cube root of 27.
Go up a little bit, otherwise you run out of space, Edward. Just do it here, would you please?
Cube root of 27 equals 3.
Yeah.
Cube root of 2197 equals 13.
So what is the 13 squared, Edward?
169.
And 169 times 13?
Is 2197.
Okay, just general knowledge, of course. Okay, fair enough.
So yeah, okay. Now let's do let's convert that to minus 3 over 13 squared. So you just squared each number now. It's effectively minus 3 times minus 3. Sorry. minus 3 all over 13 times 13. And that equals 9 over 13th. Now here's where
Hold on, 9 over 13. I thought you had 9 over 13 times 13.
Sorry, 9 over 169.
Yes.
And now this is where the minus comes in.
Because we had to the power of minus 2/3, so
Yeah.
that's going to become an inverse. Can you put the 1 over that, please? So
1 over 9, 169 equals 169 over 9. And that cannot be simplified any further.
would you double underline it for us, Edward?
That makes it confusing because that makes it seem like a fraction, so I'll get up that.
Okay.
Double
Alright, if you're happy with that,
double.
that's wonderful. Thank you, Edward. Excellent. And what's the part C, please?
Part C, let's just divide it just so the
Yes.
viewer doesn't get confused.
Indeed.
Right.
So just what does that say at the top right in the form?
Kx to the n, where k is an integer.
Okay. And n is the
a
power.
yeah,
Yes. So
Okay, so this one, anytime, if you see a numerator of a coefficient of x, always imagine an imaginary line by the x.
yes.
Imagine it's 2/3, okay?
Yes.
So the numerator over the coefficient of x. So that is effectively 2/3. And when we bring the power of x up, it becomes a minus 2. So it's going to be 2/3 x to the minus 2. Yeah?
No, Edward.
Oh no, is it not?
No. Well, it's just that last little flourish you've done, the brackets.
Yeah.
Because the 2/3 isn't to the power of minus 2, is
Sorry.
it?
So it's going to be there, sorry. 2/3 x to the minus 2.
Yes. And is it alright to double underline that one?
Okay.
Just to please me. What would you say is tricky about these, Edward?
Well, it's tricky because it's like a wolf and the sheep's clothing. It looks more difficult than it actually is, and the minus is out there to freak people out, and it really shouldn't be, because just remember you flip the fraction over.
Yes, that flips it over. Thank you very much, Edward. That's
You're
really
most
helpful.
welcome.